Polynomials have different names depending on their degree. So if the highest exponent is 0, meaning it's just a number, it's going to be called a constant polynomial because it'll look like a straight line if you remember from graphing. If it has a degree of 1, the highest exponent's 1, it's linear, which means it's still going to be a straight line, but it's not going to be horizontal or vertical. It's going to look like that. Quadratic, that's when the highest exponent is 2. Y'all remember what those look like on a graph? Y'all should. We spent like 4 weeks on it. Yes, good. Okay. And then if the highest exponent is 3, it's called cubic. So those are the only ones that I'm requiring you to kind of remember. So let's try it. Try not to look at your paper. Good morning. If I gave you this function, it's what type? Quadratic, because the highest exponent is what? Alright, if I gave you this one, constant, very good. If I gave you this one, cubic, very good. And we'll go over these so much you'll have it memorized. Alright, we talked about what a polynomial was. Let's see if y'all remember. If I gave you this, not on your notes, so you don't need to write this down. Let me write 3 equations up here. Alright, which one's a polynomial? Let's see if y'all remember. Alright, which ones are not polynomials? Y'all don't remember? This one, yes or no? No, because of the what? 1 over x. This means that x was once x to the what power? Good. Can't have negative exponents. Is this one a polynomial? Yes. What's the degree? 4. Good. What's the leading coefficient? We haven't talked about that. We'll get to that in a second. But the degree is 4 because it's the highest exponent. Is this one a polynomial? Because this is x to the what power? Good. Y'all remember that? Now we're kind of doing the same thing, except we're going to check if it's not only a polynomial, but if it's a polynomial in one variable, which just means there can't be what? If it's a polynomial in one variable, there can't be 2 variables, like x and y. So like A right there, that example, is that a polynomial in one variable? Where? This one. Yes, because there's only one variable, x, and it's a polynomial because there's no negative exponents, nothing on bottom. So the degree of this one is what? 5, good, because that's the highest exponent. Now we'll get into leading coefficient. The leading coefficient, well, first of all, back up. What's the coefficient? Just regular coefficient. Yes, so leading coefficient means that it goes with the highest power. So look at your highest power. What's the number in front? 8. That's your leading coefficient. Alright, this one's not a polynomial in one variable, but somebody tell me why. Yep, because there's 2 variables. And then the next one, is this one a polynomial in one variable? Yes. What's the degree? 4. Leading coefficient? Everybody agree? Very good. Negative 4. Perfect. Because the degree, the highest one's 8. That number in front's negative 4. Everybody understand? We're going to add one more thing to this. There's even and odd polynomials, and that depends on the degree. Okay, so like for C, the one we just did, what's the degree? And 8's what kind of number? Even. So this is an even polynomial. Because the degree is even, so the polynomial is even. This polynomial is going to be what? Odd. Because the degree is odd. So we're going to add that in. Alright, I want you to try 1A through 1C. The first thing I want you to do is just tell me if it's a polynomial in one variable. Right? Yes or no. If it's no, circle why it's not a polynomial in one variable. So just write yes or no. If it's no, then circle why it's not. Alright, hope yes or no for 1A?
Yes.
Gotcha. You can just do this one now. Is this a polynomial? Because why? Very good. Alright, Madison, yes or no on this one?
Yes.
Everybody agree? Alright, Abigail 1, yes or no on this one?
Yes.
Everybody agree? Okay. Do you have a question, Sid? Okay. Alright, next we'll do degree. So, Connor, what's the degree of this one?
6.
Everybody agree? Alright, Rihanna, what's the degree of this one?
6.
Alright, leading coefficient here, Simon?
5.
Good. Leading coefficient here, Bryant?
-1.
Everybody agree? Alright, Amy, is this an even or odd polynomial? How'd you know? Good. And Caleb, even or odd? Very good. Any questions about those? Do we need to do more of those, or y'all good? We can move on. Okay, flip it over. Alright, next thing we're going to be doing is evaluating polynomial functions. And I put a lot of problems on here, but we probably won't have to do as many, hopefully. This is kind of like what we were doing on our study guide when we're plugging numbers in, like y'all were doing for the absolute value and stuff. If it says find w of 5 and w of -4, and then they give you this function, what are they really asking you to do?
Plug in those numbers.
Perfect. So instead of wx, we'll put w, let's do 5 first, equals -2, and then we would replace x with what? Yes, 5 cubed plus 3 times 5 minus 12. We'll just do this one together. First thing I would do here is what?
5 cubed.
Yes, which is what?
125.
Good. So we can replace this with 125. We can also replace this with what? Good. Next we need to multiply. So what's -2 times 125? -250. And then we can do what right here? Subtract. 3. Good. So w of 5 is what? Very good. That's all. I want you to mark out this one, and I want you to find w -4 for the same function we just worked with. W of -4 for the same polynomial we were just working with. Alright, anybody want to tell me this one? What they got for this one? Nobody? Go ahead.
104.
Good job. You're allergic to chocolate. Okay. Do we need to go over this one? Raise your hand if you got this. Cool. Okay, one more and then we'll move on since y'all are good with this. Just find p of -6 for this function. And then we'll go over it, and then if everybody's good with it, we'll move on. Anybody need more time? Okay. All right, anybody want to share their answer? Go ahead.
46.
What do y'all think? Correct. Any questions? Here you go. Do we need to go over this? All right, so we don't need to evaluate any more polynomials. Everybody's good with this. All right, moving on. So now we're getting into graphing polynomials, and you'll see them in two different forms. We have standard form and factored form. How could you tell the difference? What'd you say, Evan? How could you tell somebody who doesn't know that these are different, the difference between them? What you said, one is the answer. So like this one, is that one you're talking about? Oh no, we're not trying to factor them. Like if I were giving you these two equations and I would tell you to graph them, and I'd say one of them's in factor form, one of them's in standard form, how could you tell the difference? Yes, that's all I was looking for. In factor form, it's going to be grouped, or you'll see parentheses. If you don't see anything grouped or parentheses, you know it's in standard form. If you see it, it's in factor form. When you're finding the zeros of a polynomial, it's easier if it's in factor form, because how could you find the zeros right here? Just set them equal to 0, right? With this one, you'd have to do like quadratic formula or factor it or completing the square or something other than this one. That's why we always want it in factor form, okay? So like for number 1, when it says find the zeros, I would just take these and set them equal to what?
0.
And hopefully I don't have to write them out. If I set this one equal to 0, just give us what? And the next one? And the next one. Good. Do 2 and 3 on your own. And what are zeros compared to your graph? Like what would these, where would these be on your graph? Yes, so your x-intercepts. These are the same thing as your x-intercepts, right? Alright, what are your zeros for this next one? Next one? Oops. Alright, where did he get that 0 from? Let me rewrite. You have to set what equal to 0 also. This x on the outside. Did everybody do that? Okay, so there's 3 zeros here, 2 of them here, 3 here. Alright, sometimes you'll have multiple zeros, which means like once you solve, you might get -2 twice in some of them. That's called a multiple zero. That's when a 0 appears more than once. More than once. Now in these, none of them appeared more than once, right? This next definition is really important. I'm not going to ask you to memorize it for the test, but you'll hear me talk about it a lot, and if you don't know what it is, you'll just kind of be lost. A multiplicity is how many times a number is 0. And instead of 0, because that kind of sounds weird, how many times a number is 0? It's how many times a number is, remember we talked about the graph? What are these that we just found? X-intercepts, good. How many times a number is an x-intercept? Which has to do with how many times it appears. So like for this first one, the multiplicity of -1, how many times did it appear when we solved for it? Just once. So the multiplicity is 1. So when you list the multiplicity, I'm not going to make you write multiplicity equals 1, just write M1. What would the multiplicity be for all of these? 1, because it only appeared once. Now, I know it feels silly to write all this out, but you're going to need this to identify the degree of these polynomials. Remember when we did the degree on the front side, it was the highest exponent? Well, what about in factored form? Could you tell me the degree here? No, right? Because it's not in standard form. But to figure out the degree of this, you just add up the multiplicities. So what's the degree of this one? Yes, there's 3 multiplicities, so the degree of this polynomial is 3, which means it's what kind of function? What kind of polynomial? Cubic. Good, I wasn't looking for that, but good job. 3 is what kind of number? Odd. It's an odd polynomial, and cubic. Alright, this one, what's the degree of this polynomial? So it's even and quadratic. What's the degree of this one? Yes. So to find the degree in factored form, you add up the multiplicities. Any questions about that? Alright, flip it. Alright, I want you to just find the zeros of numbers 4 and 5. Just these two, find the zeros, and then we'll talk about multiplicities. Alright, what's the zero that y'all found in this one? Alright, let's talk about this one. What's the multiplicity of this zero? Anybody know? It's 2, but let's talk about why. How could I rewrite x plus 8 squared? Yes, so if I set both of these equal to 0, I'll get x minus 8 twice, right? That's why it has a multiplicity of 2. Now, do I have to do this? How could I tell the multiplicity without writing it out like this? Just look at the what? Exponent. Very good. So what's the degree of this polynomial? 2. Perfect. Alright, this next one, tell me one of the zeros. I heard 2. What's the multiplicity of this?
3.
Very good. Because the exponent is 3. What's another 0? What's the multiplicity? Good. Last 0? Multiplicity of?
4.
Very good. Everybody understand how we got those? What's the degree? Somebody said it. 8. Very good. Because you add up 4 plus 3 plus 1, the multiplicities. Or you could just add the exponents from up here. 4 plus 3 plus 1. Alright, what's different about number 6 and 7? Standard form. Good. So we need to put it in factored form by factoring, okay? So how would I factor this one? Yes, which is what? Good. What goes in the middle? Go ahead. Plus. Very good. Can we do anything else with this? We can factor this part, right? What are factors of 25 that add to get negative 10? So I could write this as x and...
X squared.
Yes. I don't have to write it out twice, correct? So this is now in factored form. What's my 2 zeros? X equals and x equals multiplicity here and here. So the degree And really, you don't have to add the multiplicities here, because what's the highest exponent? 3. You know that's going to be the degree. But you can check it. Your multiplicities should add up to the highest exponent. So, like, for example, our multiplicities here should add up to what? 4. Alright. Go ahead and try this one on your own. Factor it, find your zeros and the multiplicities, and list the degree. Alright, Evan, what did you do first on this problem to factor it? Perfect. Alright, Darius, what would go in the middle if I took out x squared out of everything? Good. And can we do anything with this? Yes. Alright, Connor, what does it factor into?
X plus 4 and x plus 2.
Very good. So, Brandon, what's one of my zeros? Good. And what's that multiplicity? What's that exponent out here? Good. Alright, William, what's another zero besides negative 4?
-2.
And what's the multiplicity?
1.
And Simon, what's my last zero?
0.
And what's the multiplicity?
2.
Very good. So what's my degree? Very good. Did everybody get this on their own? The last thing I want to do with these is talk about if it's even or odd and what's the leading coefficient. We'll start with the two easiest ones, number 6 and number 7. Is number 7 even or odd? Alright, how do we know? We look at the what? Yes, and the degree is 4, and that's an even number. So this is even. Now, the leading coefficient on the first page, I wanted you to list the number, but I really don't care about the number. I just care, for the graph part, if it's positive or negative. That's all I care about. So the leading coefficient here, what's the number? 1. Is it positive or negative? So leading coefficient, I want you to put plus. It's even with a positive leading coefficient. And you'll see why that's important in just a minute. Alright, this next one, even or odd? Positive or negative leading coefficient? Good. Questions about that? Alright, even or odd here? And what do you think about the leading coefficient? Positive. Okay, so these are a little tricky. Did everybody look at this right here? Alright, it's different. This one you can do that because they're being added and subtracted. Aren't these all being what? Multiplied together. So what you have to do on these is look at the first number, but of each one. And again, we don't care what it is, just if it's positive or negative. So out front, this is what? So 3 positive numbers multiplied together would give us what? A positive number. Good. This one, even or odd? Positive or negative? Good. Alright, so why is that important? You'll see it's because of the end behavior. We have to know if it's even or positive or negative because of end behavior. Did y'all talk about end behavior in Algebra 1 or Geometry? Okay. End behavior is literally talking about what is the end of your graph doing. So basically these little arrows, okay? So what I want to look at, we're going to ignore this constant because it's different. Let's look at this one. Where is your arrow going to on the left side of your graph? So it's going down, right? On this side of your graph, the end of it, where is it going? Yes, this is the end behavior. That's how you write it. It's going down on the left side and up on the right side. The end behavior on this one, down, down, very good. It's going down on the left side, down on the right side. What about the end behavior here? Down, up. What about the end behavior here? Up, up. Good. End behavior here. Yes. Now let's see if we see a pattern. Okay. Notice that the degrees 1, 3, and 5, they're odd, correct? So look at all of their end behaviors. Just the odd ones. Now look at the even ones. What do you notice?
Even ones point in the same direction.
Yes, even goes in the same direction. Odd goes, so odd and opposite, think they both start with O. Even's going to be the same, or evenly distributed. Okay, so write odd, opposite, even, same direction. Now the constant one has a degree of 0, so it's kind of different. Notice the end behavior is not going up or down. But everything else, odd is going to be opposite, even is going to be the same. So that's why it's important to know even or odd. Now the leading coefficient comes into mind, okay? So let me write this over here. If it's odd and has a positive leading coefficient, you're going to start from the bottom. Start it from the bottom, okay? So it's going to start going down, then up. But if it's negative, it's going to be the opposite in behavior. It's going to start up, then go down. So the odd's pretty much the hardest to remember. But if you can remember that silly song, if it's positive, you start from the bottom. And now even, I'm going to write it on this side. It's easy to remember. If it's positive, they're both going to go up, up. If it's negative, they're both going to go down, down. So what I want to do before we flip pages is go back up to 4 through 7, those problems that we worked, and let's determine the end behavior for each one, okay? This was even and positive, so what's the end behavior? Up, up, good. Same thing here, correct? Up, up. This one's odd, so it's going to be opposite directions. It's positive, so we're going to start from the what? Bottom and go up. And then the last one, of course, is going to be what? Up, up. This one? Because the degree's 3. 3 is an odd number. Any questions about that? The end behavior you'll have to memorize for your test. It's going to be like next week at the end of the week. But the end behavior, you won't have a chart or anything. You're going to have to memorize it. Alright, flip it over. Oh, let's stop here actually. What I want you to do is work on your homework, those 5 problems, while you have a chance. What I'm about to do is I will call your name if you have a chance of being exempt. You know, it still depends on like if you have a C average. So what I'm going to do is call up your name. You're going to bring me something to write on. I don't care what it is. And I'm going to write down the average you have to have for this 9 weeks in order to exempt. Did I understand? The average you have to keep this 9 weeks in order to exempt. If I don't call your name, that's because you have an unexcused absence. Do not shoot the messenger. If you have an absence that you think should be excused, talk to the attendance window, okay? All right. So when I call your name, bring me something little to write on. Patrick.